Assalamu alaikum. Uh, Today we are going to discuss inverters. You already know the concept of inverter. It is direct current to the alternating current converters, similar to the rectifiers where we convert the alternating current to the direct current. This is the reversal of them. And here is the course contents for this PPT. So what we will do is in this presentation, in this part of the course, we will discuss what is inverter and what is the application of inverter, and then there comes the types of inverter, that is the voltage source or current source inverters. Then there are various implementations like single phase, half bridge, single phase, full bridge, and then we will discuss the three phase inverters with 120-degree mode of conduction and 180-degree mode of conduction. This conduction angle is the angle which is fed to the thyristor. Actually, this is the firing angle for the thyristors. Let's start. What is inverter? It, as name suggests, it is a DC to AC converter that is converts direct current to the alternating currents. And there is another operation, it converts DC to a symmetric AC voltage, and output AC is voltage changing or frequency changing. It depends. In a design scenario, technique named pulse width modulation is used with certain width of output AC pulse. That is very important. Pulse width modulation is used for the inverter operation. And types of inverter, we already know that one is a current source, other is a voltage source. The application of inverters are in adjustable speed drives, UPS. You already know that in our home appliances, UPS is one of the application which we have gone through our daily life, where we see the charge has been stored in a battery, and when the light trips, the battery will serve as a source, and that DC power is converted into AC supply, and the in between circuit is the inverter circuit. HVDC, high voltage DC transmission lines. Yes, that's pretty important, because in the case of high voltage DC transmission, since over all the system, all the power system in our country is in AC form, so to save the cost and considering some other parameters, there are two main lines in, as far as I know, high voltage DC lines exist in Pakistan also, where first of all AC is converted into DC and then step up and then fed to the transmission line, and on the other end the similar process has been conducted. One way is the rectifier, other is the inverter. And next thing is standby aircraft power supplies, that is also used in inverters. And the classifications of the inverter. Method of connection, there are three types: series inverter, parallel inverter, and bridge type inverter. And according to the nature of DC source feeding, the inverter types are voltage source and current source. One is connection type, other one is DC source feeding types. Difference between the voltage source and current source inverter. In the voltage source inverter, input voltage is constant, output voltage doesn't depend on the load. Magnitude of load and shape depends on load. Magnitude of load, current, and shape depends on the load. This is the property of voltage source inverters. How about current source? Input current is constant and output current doesn't depend on the load. And magnitude of load, voltage, and its shape depends on the load. As far as you can see that voltage source and current source inverter, load current depends load current magnitude and shape depends on the load in the case of voltage source, and current source inverter case, the voltage of the load depends on the load. Now we will discuss the voltage source inverter one by one. First of all, we will see single phase inverter, half bridge inverter, and full bridge inverter. After that, we will discuss three phase voltage source. Now remember, this is a voltage source inverter. Look at the diagram, and you will see it's much better that we are here. Look at the single phase half bridge inverter. Why it is called half bridge, I will let you know. As you know that for the complete bridge we needed 4 diodes. Now here we have 2 diodes and, uh, 2 switches. Load and supply is divided like this. The source voltage is divided by 2 is fed to the 1, and source voltage to the fed to the other. This is just a symbolic representation. Let's see. Okay. Look at here. This is the load voltage across the load, and this is the IS1. This is the current through switch 1. This is current through switch 2, IS2, and then the load current. Okay. First of all, when this S1 is closed, what will happen? The current will flow to the S1 and load 1 with the polarity plus minus. Okay, and it will show over here like this. This is the load voltage because it is a positive. Okay, and similarly the current shape is like this. It's a positive, it's also positive on the positive side, and during the next cycle, and this is the load current. This is current to the switch, and this is the shape of the load current. Shape of the load current always follows the shape of the load voltage. What happened next? In the next cycle, the switch S2 conducts. Now the direction of the conduction, you can see that here the polarity is different as compared to the previous one. Now current is flowing in another direction, plus here, minus here, and it is, we consider the load voltage, it is inverted as compared to the previous case. इसमें देखें पिछले केस से ये इन्वर्टेड होगी, that's why it goes downward, and similarly the current S2 is like this. However, if you see the direction of the switch S2, the current flowing in the same direction as in the S1, so it's have the same polarity as the switch 1 current. And however, in the case of load currents, in the polarity in the load is inverted, it is given by like that. It is also inverted in the case since the load voltage is inverted, so that the load current. Okay, you need to be careful about this. This is direction of the current in the switch is the same. Okay, it is going downwards, it is going downwards. Okay, it is going downward, it is going downward. Okay, let's keep moving. Similarly, for the next cycle, S1 is conducting again, flowing through the load with this this is the load voltage plus minus. This convention is taken as plus, so as the switch current follows this polarity, and it is shown like this. And the next one is, if you see the load current, it follows the same direction as compared to the that one. And let's go back to the next cycle, which also follows the same direction. Come back over here, you will see this is the direction we are looking at. It is inverted, and so that the load voltage, but the current through the switch is the same. That's why it appears to be same. Okay, and however the load current is inverted. Now you can clearly see the inverter operation in this case, which seems to be very appealing, as far as you know that in the case of voltage inverter, this is a voltage inverter. What will happen? Load voltage doesn't load voltage doesn't depend on the load voltage does not depend on the nature of the load. However, load magnitude of load current is decided by the nature of the load. Okay, which is proved to be. However, input voltage is constant, and load voltage doesn't depend on the load. Okay, it's just depends on your. It doesn't depend on the load. However, the load current depends on the load. Okay. Yes. Next, for RL circuit. Actually, in the RL circuit is a very interesting circuit. In that case, you can see that when you connect an inductor in the circuit, uh, it gives you some interesting features. Uh, this is the voltage source. These are the capacitors. Capacitors serve as the purpose of maintaining the voltage. Okay, here you can see that this is your voltage Vs2, and Vs2 or this is the case when this Q1 switch is operating. Okay, and this is the case. uh, this scale waveform is for the resistive load. However, we know that the and this the for the other circuit, what will happen when Q2 is fired, the polarity is reversed, and you know that this is going the other way. This is the same circuit as you seen in the previous figure. This is the same circuit, just we have included inductor in the circuit. What will happen in this case? This is the fundamental component of this uh, output current. Although the current is a fluctuating value, however, uh, by the use of a highly inductive load, you can smooth out. Look at this one. Initially, what will happen? You also one thing, current always lags behind the voltage by a certain angle, which is the property of the uh, which is the property of the inductor, which is lag behind a certain volt. You need to be careful about this convention. You already have a very now at the end of the course you have a lot of experience regarding the inductive load. Inductive load always have interesting consequences on your output. And this initially you see in the previous case your load current is like that. It's just a group, just is shape is like that. Okay, it is just a group. Now you can see that it is smoothly changing, like it's kind of rectangular, triangular shape. Initially it's just a jump, like like this one. Okay, this is the stability is full page. inverter. The difference is between the half wave and full wave is the number of diodes and the number of switches S1, S2, S3, S4. In the case of half wave, we have only two switches. Here we have four switches, and load is connected in between. Let's see the okay. Okay, this is a circuit diagram. No, actually, this switch is actually IG1. It could be IGBT. It could be anything. Suppose you connect to two IGBT. IGBT is a switch, S1 and S2, and you fire these two at a certain time. The firing angle is adjusted so that they conduct at the same time. The direction of the flow of the current to S1 and S2, and this is given like that. Okay, IG1, IG2, and you have a pulse until this duration, and this is the direction of the current marked for the clarity, and this is the output voltage. You can see the polarity of the output voltage always follows the direction of the current, and it really shows you this thing. And how about the next thing? Now you have given a pulse to switch 3 and 4, and what will happen in this case? Now you have a different scenario. What is the scenario? Scenario is that the current direction is through the load has been reversed. Initially the current is flowing in this direction. Now depending on the circuit configuration and switch arrangement, the direction of the current through the load has been reversed. However, this current is shown to be positive through these switches since it has taken the same direction as S1 and S2. However, based on the direction of the current, the voltage has been inverted, and you can clearly see this inversion in the output voltage. Similarly, in the next cycle, same thing repeats. Current is flowing in the upward direction like that, and voltage is produced in the same way, and similarly voltage is produced in the same way. Actually, here the voltage has been flipped. It should be there. It should be there. This is some graphical mistake. There should be dot over here. Okay, because this current voltage we follow this current, and okay. Similarly, in the next cycle, this thing repeats, and you have output like this. And for an RL load, it becomes more interesting. Okay, how it becomes more interesting? This is just the symbolic representation. These capacitors are there to maintain the voltage across them, and these diodes are there to protect these IGBTs from the reverse voltage. Actually, when if this Q1 and Q2 is working, then the opposite voltage will appear across these two IGBTs to protect them, the protection against the voltage. We need to connect these diodes. These diodes serve as a protection purpose, and you already know that with a highly inductive load, what will happen? Your load current will be smoothed out. Initially, you can see that this is your output voltage, and your load current will follow this output voltage, and it is in the scale shape. However, using the highly inductive load, what will happen? It will be smoothed out, and it will be like a triangular waveform. And it is very clear, you already know the inductor property which doesn't allow the current to change abruptly like that. Okay, inductor don't allow to change the current through its abruptly. And similarly, okay, this is the complete explanation. Then diodes D3 and D4 are conducting. Okay, D1 and D2 are conducting. Okay, This is a portion D1 and D2, D3 and D4, and this is the next two. We will stay in this lecture until this full single phase half wave case, and we will take a review of this lecture. We just repeat uh, inverter, what is inverter, and types of inverter based on DC source feeding and method of connection, difference between voltage source and current source inverters. The voltage source input voltage is constant, output voltage doesn't depend on the load, load current and its shape depend on the load. Okay, and the current source, currents are constant and load voltage depends on the load. Then the types we have discussed: single phase, half wave, full. We have discussed in this lecture half wave, bridge and full. Then we see the diagram, what is single phase half bridge inverter and its operation. The operation, be careful, only one switch works at one time, and accordingly the waveform, if we look at, should be careful about that. Okay, this one is over here. If S1 is conducting, we have output voltage, load voltage switch and load current. S2 is operating, then we have opposite output voltage depending on the direction of the load. Similar is the next cycle of the, for RL load, your output will be smoothed out. Initially the load current is like that, then it will become the triangular, and it will help to smooth out your output voltage instead of being the square shape or pulsating, which is a triangular shape. Then we discuss the single phase full bridge. What happens in full bridge? We have 4 switches connected within the load, and what it will help the circuit work like that. 2 switches are prepared at one time, and then voltage will follow the current through the switches. Similarly, the output voltage is inverted in the case of S3 and S4, and your output waveform is inverted. And similar is the case in the next case. And for RL load, same condition. You have 4 switches, but the difference is RL. Your output will be smoothed out. Instead of the current looking like this square shape or pulsating type, it is smoothed out to a triangular shape. Thank you very much.